So continue on with number 7. We are going to have another trig problem. We're going to label a triangle, and we're going to have H, O, and A. Okay, so again, looking at SOHCAHTOA, it looks like we have O and H, so we're going to use sine. So sine of 40 is equal to O over H, which in this case is no x by itself. We're going to multiply both sides by 80. These are going to cancel, and we're going to have x equal to, and we're going to type in 80 sine of 48, which is equal to 59.452, and this one actually has units, so you're going to go ahead and put those feet. Forgot to box this one, so I'm going to go ahead and that. And then the last one here is last trig problem. So we're going to do our O and A. It looks like we have O and A this time. We haven't had in a while, so that's going to be our tangent, which means we have the tangent of 45 is equal to, for A, which is 60 over x. We're going to switch them like we did before, so x is equal to 60 over the tangent of 45. We did that because the x was on the bottom. We're going to type that in. Oh, let me show you my calculator. There we go. 60 divided by the tangent of 45 is equal to 60. Would you look at that? Another 60 feet. Alright, if you know that this is really a 45, 45, 90 triangle, so that's one of our special right triangles, and we know that in a 45, 40, 90 triangle, your lines are the same length, so since this one's 60, this one has 60 as well. We just showed that through trig. Alright, so let's move on to topic 18. Let's see if this glare is stopped. Could I turn this down maybe? There we go. Alright, so we're just Pythagorean theorem to solve for x. So our Pythagorean theorem is our a squared plus b squared is equal to c squared. Our c has to be the hypotenuse. Alright, so look at this one. We're going to set it up as x squared 9 squared is equal to 16 squared. And these, we have to leave our answers as simplified radicals. So we have x squared plus 9 squared, which is 81, is equal to 16 squared, which is 256. We're going to subtract each side by 81 to get that x squared by itself. So 256 minus 81 is 175. And then we're going to square root both sides. So x is equal to the square root of 175, but let's see if we can simplify that at all. So we can divide by 5. So 175 breaks down into 35 and 5, which 5 breaks down to 7 and 5. We can't break down those any further. We have of 5s, so that is going to go outside and 7. So that answer is going to be 5 root 7. Looking at our next one, have square root of 5 squared plus x squared is equal to the square root of 14 squared. Alright, so the square squared, those are just going to cancel. We're going to get plus x squared to the square root of 14 squared, which is just going to cancel and get us 14. We're going to subtract our 5 over and get x squared is equal to 9. And then we're going to square root both sides. So x is going to equal 3 because the square root of 9 is 3. And our next Pythagorean theorem, so again we have a squared plus b squared equals c squared, where c is our hypotenuse. So here we have c, and either one can be a or b. So I have x squared plus square root of 6 squared is equal to square root of 2 squared. Becomes x squared. Again, our square root and squared are going to cancel, so that's going to become our 6. In this case, we distribute that squared. So 2 squared is going to be 4, and the squared is just going to be 2, and that means that this over here is 8. X squared plus 6 is equal to 8. I'm going to subtract 6 on both sides, so x squared is equal to square root of to undo that squared, so x is just going to be the square root of 2, which cannot simplify. For the next 3, we'll use the Cont Pythagorean Theorem to determine if our triangle is acute or right. Alright, so our first step is to figure out which side is the biggest, and that's our c squared. So we're going to have a squared plus b squared is maybe equal to c squared. We're going to see how this squared relates to squared plus b squared, and that's going to help determine acute, obtuse, or right. A squared, squared is equal to c4, 7 squared is equal to 49, and 12 squared is 144. So 6 plus 49 is going to be 113. Compared to 144. Our c squared is bigger than our squared plus b squared, and since it's big, that means that it's going to be obtuse. Alright, let's try the next one. So 15 is going to be our biggest, so we're going to have our two smaller ones together, so a squared plus b squared is maybe equal to c squared, which is 15. 9 squared is 81, plus 12 squared, which is 144, compared to 5 squared, which is 225. So 81 plus 144 is equal to 225. Those are equal to each other. Whenever they're equal, they're going to be a right triangle. And in our last example, we have 8 as the biggest. Now, don't be confused since they switched up the... So we're going to have 7 squared plus 6 squared is maybe equal to 8 squared. Alright, 7 squared, 49, 6 squared is 36, 64. 49 plus 30 is going to get us 85. 64 is smaller than our a squared plus b squared. That means that it would be acute. Alright, so that was our topic 18. Let's move on to topic 19. So looking at topic 19, so again, we're going to leave our answers in simplest radical form. This is where we have our 45, 45, 90, which if we have 45, 45, 90 triangle, then our ratio is going to be 1 to 1 to square root of 2. If we have our 30, 60, 90 triangle, then our ratio is going to be 1 square root of 3 to 2. Okay. So looking at this first one, we have 45, 45, 90 triangle, so we're going to use our 1 to square root. And we're going to put the smallest size and the largest sides in their corresponding part. For 45, 40, it only really matters where you put your hypotenuse, which needs to go under the square root of 2. This is 2 square root of 2, and then you can place your x and y wherever. You have that, you're going to solve, and for this we want to go back to one, so we're going backwards. Whenever we go backwards, we're going to divide by what we started with, what's the top of the ratio. So we're going to divide by that square root of 2. So x is going to equal 2 square root of 2 divided by square root of 2. Our square roots of 2's are going to cancel, so x is equal to 2. And since we have a 45, 45, 90, the legs are going to be the same. So if x is 2, then y is 2 as well. Alright. For one, we have another 5, 45, 90 triangle. So again, we're going to use 1 to square root 2. This time we were given a leg, so that leg will go first. The other leg is the second spot, and our hypotenuse are x. Know that the legs equal the same thing, but if we're going forward, we're going to multiply by whatever we're ending with, so we're multiplying by 1, so that's going to give us that y is equal to 4, because 4 times 1 is 4. And then we're going to go back to this 4 and multiply to x. So we're moving forward again. So we're multiplying by the square root of 2 now. So 4 times the square root of 2 is just 4 square root of 2. And our last one is a 30, 60, 90. So we need our square root of 3, 2. And we're going to put the corresponding parts, so small, medium side, our small side y, because it's opposite of 30 degrees. Our medium side is 5 square root of 3, because it's opposite of 60 degrees. And our long side is going to be x, because it's opposite of our 90 degrees. For this one, we just want to get back to square 1. So to do so, we're going to go backwards, and we're going to divide by the square root of 3. We're dividing by whatever we started with. So y is equal to 5 square root of 3, all or the square root of 3. So the square root of 3's are going to cancel, so that y is going to 5. Alright, so now that we got that y is 5, we need to go forward in order to get x. And since we're going forward from our beginning, always starting from square 1, we're going to multiply by 2. So x is going to be 5 times 2, which is just 10. Alright. Moving on, we have topic 20, and topics where we just kind of give you an angle, and you're going to for the unknown side length or the angle measure using what you use. These first 4 problems are just asking whether you would use trig, Pythagorean, 30, 60, 90, or 45, 45, 90 special right triangle, and you don't actually have to solve them. But which way would be the best way to solve? So looking at, we're given an angle measure, and the angle measure is 45, right? So since it's 45 and a 90, that means this other angle is 45. So then we have a 45, 45, 90 triangle, and in that case, we can use our special right triangles, and in this case, it would be a 45, 45. Alright, the next one, angle measure of 60, which means this one has to be 30 because all the angles in a triangle add up to 180. At this one, the special right triangle with 30, 60, 90. So this is again a special right triangle, 30, 60, 90. Alright. 27 only gives us 3 side lengths where we're solving fun, but it gives us the other 2, but no angle measure. So since we have no angle, that's going to rule out special right triangles, and it's going to rule out trig. So the only thing we have left is Pythagorean Theorem. Okay, and our last one, we are looking for an angle that we don't know, and we have two side lengths. So since for a missing angle measure, and it doesn't look like these have the relationship that we need to for a 30 or 45, 45, 90, so we can go ahead and just use trig for that one. Alright, so let's put this to the test. Looking at this one, we're going to solve the triangle. So we're solving for all the missing side lengths and all of the angle measures. So the first thing that looks like the easiest is solving for a. I'm just going to make that x. We are given two sides, so I think the best to do this one is using Pythagorean Theorem. So since we have no angle measures, that is going to be the only way to do this one. Alright, so we have that x is actually a leg, so it's going to be x squared plus 7 squared is equal to 15 squared. X squared plus 7 squared, which is 49, is equal to 25. We're going to subtract 49 from both sides. And we get that 225 minus 49 is equal to 176. Alright, so let's see if that is. I'm going to square root both sides. So to the square root of 176, let's see if that simplifies down any further. We know that we can take out 2 from it. So 176 breaks up into 8 and 2. This can break up into 48 and 11. 8 breaks up into 4 and 2, and 4 breaks up 2 and 2, so we need groups of 2, 1, whatever. You have 2 groups, you're going to put those on the outside and multiply 4 root 11. So let's see if that works. Yeah, that is going to be our simplified version. So A is going to be 4 root 11. So now that we have that is 4 root of 11, we can solve for the measure of A and the measure of angle B. Angle A, Y. And it looks like we need to use trig here. So I'm going to label my triangle based off of A. So that becomes H, O, and A. So I don't want to deal with that 4 root 11. So I'm going to choose to use sine and use these pretty numbers 17. So of y is equal to 7 over 15. Alright, to undo that, use the inverse. So y equal the sine inverse of 7 over 15. If I type that in, then I have second sine of 15. That's going to give me 27.818 degrees. Same idea with B, so I'm going to use B in this case. So the angle measure of angle B, I'm going to use Z. And I'm going to relabel my triangle based off of B, so I still have H over here, but now and A are going to. So I still want to use these pretty numbers, so I still want to use 7 and 15, but this time that's going to make that cosine, and that is going to be A over H, so it's still 7 over 15. Let's use my inverse. So 15, and second over 15. Is equal to 62.182 if I round. Alright, and that is completely finding all side lengths and angle measures for that triangle there. The next one we're going to look at, it looks like missing some more. The measure of angle A shouldn't be too difficult. We don't need to use Pythagorean Theorem, special right triangles, or trig to solve this one. We know that all of the angles in a triangle at 180. We have 90 and 62, so we just have to subtract their sum from 180. So actually the measure of angle A going to equal 28 degrees. Alright, so now we need to figure out which side we are looking for. So look for AB first. Since this 36, 45, 45, 90, we can't use special right triangles. We don't have sides, so we can't use Pythagorean Theorem. So in this case, we have to use Trig. You can decide which you want its angle to be. I'm going to use the one that's given. H, O, and A, we have 16 and we have X. That is going to be cosine. So we have the cosine of 62 is equal to 16 over X, which means we are going to switch to, so X equal to 16 over the cosine of 62. Type that into our calculator. 16 divided by 62 is equal to 34. That was AB. 34.081. We're going to do that same exact thing for AC, and we can reference angle B, but now let's change this variable to Y. But now we don't need X anymore, so I'm going to use 16, which is A, and Y, which is O, so now I need to use tangent. So the tangent of 62 is equal to O over Y over 16. In this case, we could just multiply both sides by 16. Type in tangent of 62, and you should get 30.0916, or we can round that to 0.092. So we get for this one 30.09.